Hello and welcome back to compiler programming. Today I want to work on this issue, which is around passing void values as arguments. In reality, it's not just void values, it's sort of any kind of zero-sized values. And I spent some time to try to understand what the ABI actually says should happen here, which is not very straightforward. So both specification, like Windows 1 and System5, don't explicitly call out what happens, but at least for the System5 ABI, there is a GCC extension, and if we go to Clang and find something, yeah, x86-64, that sounds good. So I think they both agree about what should happen here. Yeah, so what happens here is if we have a zero-size struct, then we kind of just ignore it in the list when we try to figure out which value goes where, which for System5 ABI kind of makes sense, even though it's not explicitly called out. But for Windows, I have no idea at all what's supposed to happen. I think, like, if we read just literally, then it's supposed to be passed by reference. But that sort of also doesn't make sense because, like, you can't pass a reference to nothing. So I don't know. Like, this is a very weird thing. The only place I think I can look into this is in Windows version of Rust, probably, but I'm not so sure. Like, because, or I can also try to compile it in the sort of ClangCL version of C, but anyway, this is going to be a separate thing altogether. Right now, there is a more immediate problem that the code of compiler is very unhappy about this. And yeah, let's just see how it goes. Let's start with the test, and we will say something like this. Should be able to pass an empty struct as an argument. Okay. Now in here we actually need a couple of functions, I think. Let me grab this whole thing. Yeah, so this will return us, well, let's say it will return a U64. Yeah, it accepts a U64. This is going to be a bit tricky. Again, because MSVC doesn't actually support this, which means we need to do all of this on the inside of our code. But I guess we can do that. We accept X, which is going to be a void, and then we accept Y, which is U64, and we return U64 test. Called F, I don't know. And then here we just say this, call F with a void, and we will also pass whatever the outside function passed us. Something along these lines. Okay. We don't need this. And then we say checker of 42 is 42. Okay. We can focus this test and we can try to run this. Okay, so this is exactly what I expect to happen. Again, this was the issue. We tried to reserve stack for 0 size, which doesn't work, right? Okay, let's try to figure out what actually happens. Okay, so this is the code. We have one like this. So yeah, like this actually better. So I look in the center of the screen. But yeah, this is the code for calling the function. And somewhere in here, we need to sort of short circuit if we realize that we have a 0 size. Now, where does that happen? Okay, implicit pointer, void pointer. Okay. So what we're going to do is we're going to say the following. If call from need to get used to MSVC because I actually switched from C-line to MSVC. Yeah, it will take some getting used to. Call parameter descriptor bit size is 0. Then we just do, and this is so just be able to actually break here. And let's try to restart. Okay, this is our parameter. We have our void descriptor, everything as I thought. Now the question is, what is the storage that we figured out? Yeah, so as I don't know what's supposed to happen on Windows, so maybe I'm not so concerned with the storage. If it's uninitialized, okay, then we reserve. Yes, I think we can actually do the following. We can move this in here and we can say storage source storage is storage immediate with bit size, and then we say 0 0. I don't like auto formatting, so I'll have to figure out how to disable this, but whatever. So we say 0 sized values do not really exist, so we don't need to worry about their storage slash passing. Okay. Well, let's see if that does anything. Okay. So something else exploded? Let's see what exploded now. Value init. I think I target param descriptor. Why is target param descriptor have a different size? That's very interesting. Oh, okay, so what is target param? Right. Right. So I guess this needs to go even more up. And in here, we okay, let's do bool is 0 sized. So here I'll add to do and figure out what should happen on Windows really. But for now, let me add much more information because I might forget what I was thinking. And see if we should not treat 0 sized as implicit pointer, even though it is not exactly 2, 4, or 8 bytes as the calling convention doc suggests. And let's actually add a link to this. I will go and explore this, but for now this should fix our problem. Okay. Let's try this out. Bit confused. So we are actually, I guess we are unhappy here. We are unhappy here because yes. Yes. Okay, so yeah, the Windows is a bit screwed up, unfortunately. I think we have to do it before. So what's happening is, to explain maybe a bit better, or at all, again, if we look into the calling convention here, it says it's if it's not one of those things. Let me zoom in so you can actually read. If it's not 1, 2, 4, or 8 bytes, then it must be passed as a reference. This is what is implemented inside of the calling convention code in here, which I can actually also show. If I can find it, that would be great. Calling convention, and guess let's find Windows or something. Yeah, so as you can see here, we basically say if it's 64, 32, 16, or 8 bits, then do that, otherwise do this kind of storage. Okay, but what that means is it's, again, really unclear what's supposed to happen for 0. I guess it's supposed to go through this thing, but then in my code, I need to take special care to not do weird stuff. Yeah, I guess we do it like this. Okay. Go like this, and then we need to init this stuff. Okay. Call param descriptor, call param storage. No. So how do I rename this? Control R, Control R. We call this 0 storage or storage. Okay. Hopefully it didn't change too much. Void storage, void storage, void storage. Okay. Let's try this again. Actually, now we can break here. And we can... Okay, so this init actually works. This works. Great. This one is not 0 size, so something actually happens. Fine. Great. Now the question is, does the rest of the code of the function actually work fine with this? I think now we are actually copying. This implicit pointer just isn't, it's infecting everything. And here we'll try to load address of nothing essentially, and it's not going to be great. That's kind of interesting. Okay, let's do a hack. can say is 0 sized. Let's do it again. Can say next day, where's continue? Yeah. Okay, so 0 sized is true. Now we step over and we don't do anything for this thing. Realistically, we probably should load a 0 in there, because otherwise we have garbage. But I'm not sure that's like. Let me add this to the main comment because it's this should be maybe in one place. And here's a maybe we should load 0 into this register to avoid people trying to cast and then write to it or something. Because we'll just have garbage and you will try to write in the garbage. It's rather you will have a null pointer exception, which is a bit easier to catch. Now, anyway, let's try to run it again. Okay, so I think that worked. Oh, maybe it didn't. Okay. So that actually seems to work now, which is nice. We should test this on Ubuntu. So again, I don't know if it will work. Go mount, see the mass. Okay, so this sort of works, but it only tests our internal code. Now we just need to add a similar test, but for if def I think I can look into here and see. Okay, so it's if defined clang. Okay, should be able to find, and in here we can say zero size. Okay. Now we just need to return X. So this test is exactly the same as this one. The only difference is in here we sort of implementing the check fully inside of our code. So I create inside of my compiler a function that accepts a void and the value and then returns that value. So I know it wasn't the right register. But because sort of I both create the function and I call that function, they match, right? Which is good. It's a good test to do. But this test is sort of making sure that the Clang or GCC compiler, they agree with my compiler on what's supposed to happen to zero size struct, which is what I was showing you in Compiler Explorer. this is a test for this. And I don't need this. I can technically make this a bit shorter. Actually, this. Okay. So again, this should still work because we don't compile it. But in here, we should actually get the test. And it seems to work. Let me refocus it and see that it actually correctly... I guess it compiles it in GCC and not in Clang. Do I have anything about GCC? No. Is it like GNU something? Yeah, if it's defined. Okay. Let's try that again. Okay. Lots of unhappy stuff. Right, now I need to do struct zero size. Okay, so it is unhappy. Access elements in zero struct initializer. But if I don't pass anything, then I think it's still gonna be unhappy. Because there's not gonna be anything in there. No, it's actually happy. Okay. That's fine. How do I force it to do Clang though? Okay, so I need to say cc Clang. Not really what I wanted. Whoa. uh, mm, I guess Clang is a bit unhappy about this. But you know, I think I'm doing some kind of obj dump. Yeah, let's stop doing that. Let's just stop doing that. That obj dump was for an old setup that I had where I was using VS Code to debug on Linux. I actually might still need it, but for now, you know, it's okay. Okay, so both GCC and Clang are happy with the way this turned out. So that means my colon convention code is actually correct, which is very nice. I was expecting that I might have to change something there, but apparently just implementing the algorithm results in the correct behavior, which is great. Yeah, I guess that's about it. Again, I have no idea what I'm gonna be doing for for Windows. Like all of this stuff is very weird, and I don't want to go through setting up Rust and everything right now. But maybe, I don't know, I'll write a comment if I figure it out, or write it on the issue if you're curious about what is actually the right answer in here, and if there is even the right answer. I guess one thing I could try right now, finally before I sign off, is I do have yeah, So I think I can do test, but yeah, I can do this. That doesn't really work. Brittle H line 2866. Okay. So what is it? I don't know how much I want to debug this, but let's spend just a second on it. Line 2866. So that's not something interesting. Okay. So that is kind of curious. Let me recheck. Let me change the name. I should agree with the C compilers about zero-sized struct ABI. Okay, so this is kind of cool. This means that whatever I'm doing is the same thing that ClangCL is doing, and I believe ClangCL is developed by Microsoft, which means that they internally decided that that's the right thing to do, which is great. And what that means is, yeah, the way you read the calling convention is exactly what it says on the label. Since 0 is not 1, 2, 4, or 8, it is passed by reference, but there is sort of nothing to pass by reference, and it doesn't do anything. Now I could try to trying to figure out what exactly happens in here is gonna be a bit tricky. One final thing I want to see is what actually is inside of that register, and I think I can do this and see what happens. Okay, so I get in here. So yeah, that's not really helpful, and I removed the debug. Yeah, I guess we'll do another video in debugger, where we should be able to print out the register. But yeah, it was much easier than I expected, and I'm happy it worked out. If you stuck with me through all this rambling and you learned something, then thank you very much for watching, and hopefully see you next time.